we would like to invite Professor Chen Jiwei.
Good evening, everybody. First of all, I'd like to thank the meeting organizers for giving me this wonderful opportunity. And today, actually, I have been thinking what's the topic to share with everyone. And end up, I want to emphasize the effective vaccine is the solution to end the COVID-19 pandemic. So Dr. Zheng asked me to talk about what type of the vaccine and the related challenges. So I put this as the first slide to share with you. Basically, at the bottom here, you can see, and there's a multiple type of the vaccines can be developed. Actually, since the beginning of the pandemic, there's over hundreds of the vaccine candidates have been quickly developed and then been pushed into the clinical development. But at the end, we know that only a few succeed for the emergency use. One is the mRNA vaccine, that's a nucleic acid-based vaccine. Then the other one is the inactivated vaccine. Basically, it's the virus being killed by certain chemical treatment. Then the third type is a viral vector-based vaccine. The major two types both actually engage the adeno vector as the delivery system. So as you can see here, for vaccine development, the most important things are two things. One is the safety, the other is the efficacy. Basically, you want to make sure the vaccine to be very safe for human use. At the same time, you want to demonstrate the efficacy in clinical settings. So on the left side bottom here, I have this busy table. You don't have to read, but I can tell you the top 7 candidates right now under the emergency use. Actually, they meet the minimum requirement. First of all, majority of the individual after they receive the vaccine show safety profile is acceptable. At the same time, they at least achieve over 50% of the clinical efficacy. So this is against the wild type virus first identified outbreak in China, and everybody knows that. So then for the importance of the vaccine, historically, we know that there's different settings in the context of different types of the viral infection. And here, I basically share with you, and color-coded, you see the little man. The blue one basically not immunized, and they are healthy, but the yellow one are the immunized, healthy, but the red one is actually developed severe disease or even death. And under different scenario, if the major population, this is the human population before the COVID-19 outbreak, basically none of us actually immunized for protection against this newly emergent virus. And therefore, once this virus hits the population, majority of us will eventually become sick and develop certain disease. And the death rate can be high. So during the Spanish flu in 1918, over 500 million people on Earth infected, and they kill about 10%. This is 50 million. And then after, about 40 years later, when Asian flu was outbreak on Earth, and some of the individual already become the yellow man because some cross-protective immunity developed, but because majority of the human population is still blue, that's why they are highly susceptible. But this time, although only 4 million people infected, but actually the death rate is much higher, 50%. So they kill 2 million on Earth. So this kind of issue basically is when we're facing an emerging infection and we do not have a vaccine for prevention, that's the often consequence we get. And for COVID-19 on the left side is the situation in New York City. And during the first major wave of the outbreak in New York area, and you can see about 10% of deaths been documented also with this deadly virus in the most modern city on Earth, right? Still have this kind of a consequence. But the only way to deal with the vaccination, deal with the outbreak like this kind of newly emergent infection, I personally believe vaccines is the only solution. But when people deal with infectious diseases, there's two terms are very important. One is the personal hygiene, basically isolate from the source of the infection. This is what we are doing, the personal masking and the social distance, and also the infected people for necessary quarantine. All those are very important issues for disease prevention. But the second one is the vaccine. And I'm going to emphasize this because vaccine is the only biomedical means we can use to eradicate the infection, and the smallpox is such an example. So Hong Kong did a very good job in terms of using the Trump-1, basically isolate the source of the infection and by performing the population hygiene very well. So that's why up to now, we only have around 213 deaths overall, and the overall number of the infection compared to many places on Earth, we are still showing we did a very good job in terms of the use of the Trump-1. But the issue is the pandemic is not going away. Now, this is the situation we experience in Hong Kong, although our whole population tried very, very hard in terms of doing the personal masking, but still one wave after the other. And recently, we are facing the Omicron. So that's why, and recently when we hear the announcement from a chief executive about we have to do more stringent quarantine, all isolation and all the measures, and whole people, especially at the time before Chinese New Year, we feel very kind of depressed, right? Personally, I also feel it's quite, if we have other measures, certainly we can do better. That's the vaccine. So then talking about, although we did very well for using the Trump-1, but in terms of the vaccination using the Trump-2, so we still have gaps for protection. So Dr. Gao already mentioned, and up to now, this is the data based on the yesterday I downloaded. Actually, there's still major gaps. If we look at the different aging groups, especially for the people elder than more than 60 years old, there's still high percentage of the individual have not been vaccinated, but this population are highly vulnerable to the infection. At the same time, they also have relatively higher death rate. So this is the major task population. We still have to push the vaccine coverage so that we can achieve better protection. So then at the same time, the COVID virus, SARS-CoV-2 is an RNA virus. The mutation is the natural process of the viral evolution during the co-evolution with the human population. So on the left side, you can see there's a single mutation introduced into the virus envelope, and then this virus becomes very aggressive in terms of the transmissibility. And if you look at this arrow indicating February 20, this time, to the time the virus is completely spread out throughout the whole world, and only takes about 1 month's time. Okay, so this is the speed when the virus becomes very aggressive in terms of increased transmissibility. But at the same time, on the right side is what happened in Hong Kong in terms of the population vaccination. If we look at the coverage from the time we started the vaccine to 50% of the vaccination, it took us over 9 months of the time to reach 50% of the coverage. And if you look at the situation, compare with the virus and the human, and we can clearly see what we have been doing in terms of doing the population vaccination. We lost the competition when we compare with the speed of the virus spread. And then the most recent big issue is the Omicron, right? So Omicron has showing different, this is the historic, basically in the recent 2 years, the mode of the viral spreading, talking about the different variants. And then the most recent Omicron, you can see the speed of the transmission is even higher than the Delta, about 3 to 5-fold higher rate of the transmission. And certainly putting the tremendous pressure on the development of an effective vaccine to cover the newly emergent variants of concern. So then talking about the vaccine-induced protective efficacy, and we know that the vaccine actually against the wild type from the beginning is very good in terms of reduce the death rate, induce the rate of the hospitalization, but in terms of preventing the viral nasal transmission, actually they are not very high. For example, the vaccine AstraZeneca, the standard vaccine regimen, they can only achieve about 4% of efficacy in terms of the preventing the viral transmission. And then for the BioTech, this is the vaccine we are using in Hong Kong. Although there's increased efficacy compared with the AstraZeneca vaccine, but still it's not over like 80% as we expected. Then when our group did the research using the hamster as a model, we found out that the systemic neutralization antibody actually had a hard time to reach the mucosal surface to build the layer of the protection at the site of the viral entry. That is why current vaccine still need to be significantly improved to achieve the preventing the nasal transmission. And that is the key to stop the overall global spreading of the viruses. Then recently, I believe Dr. Tou and Dr. Hang will also mention this, is the comparison of the BioTech of the Sinovac vaccine among the local vaccinees. And we can see that in terms of the neutralization antibody titer, certainly the BioTech is significantly better. But even with this better immune responses when deal with the Omicron and compared to the level of the protective antibody actually already reduced about 44 when we compare with the wild type prevention. Basically, the mutations generated in the Omicron viruses already shifted. And that's why there's an urgency to develop the Omicron targeted vaccine as the more effective way for further prevention. So then we also had 2 cases who actually been fully vaccinated with the mRNA vaccine, but later on being infected by the Omicron variants. What we see here, very interestingly, these viruses after infection, they can boost the neutralization antibody in both cases, and the level of the neutralization antibody can actually against all the current variants being identified, suggesting if we design a vaccine using the Omicron targeted immunogen, actually we can potentially induce broad protections against all current vaccination. So this is telling us inventing and getting the new vaccine ongoing is the really urgent issue. So then which vaccine has such high potential to be quickly developed? Basically, the mRNA vaccine is the top candidate. At the same time, the nucleic acid-based DNA vaccine is another type of vaccine should be considered. And in terms of the traditional viral vector, inactivated viral vaccine, this is the Sinovac and the Sinopharm. They developed this type of vaccine. Currently, we still do not know whether the Omicron virus can be readily grow in the cell line they use to produce the wild type viruses. So this is a technical hurdle, and we hope they can overcome this hurdle and generating the inactivated vaccine as well. But certainly, as I shared with you in terms of inducing the level of neutralization antibody for protection, the nucleic acid-based vaccine is very, very essential. And then lastly, I just want to mention the 2 vaccines we invented at the University of Hong Kong, and the paper recently already published. And in this study, we actually invented a DNA-based vaccine called the IC-COV, and then followed with the intranasal boost. And this actually is the, we call the vaccine regimen number 4, and the color-coded. And in the 2 different animal challenge model, only this DNA vaccine prime, then followed with the intranasal boost, we achieve nearly complete protection against viral replication, both in the lung and also in the nasal cavity. So far, this is the only published vaccine regimen showing such efficacy and invented locally here. So I was very pleased to hear what Dr. Gao mentioned earlier. If we can quickly develop this vaccine locally, then we have a very high competitive edge in terms of the new vaccine development in combating the emerging variant of SARS-CoV-2. So recently, actually, we already made the ISO-CoV-2 by using the Omicron as a target. And this is the data we just generated yesterday. And only after single vaccination with this DNA vaccine we called IC-CoV-2, we already induce the neutralization antibodies in animals. And if there's a booster vaccine through either intranasal or using IC-CoV-2, we expect to see the higher protection event. So basically, that's what I want to share today with you. And thank you for your attention. And here are our collaborators, and I want to thank them, including Professor K.Y. Yuan, Honglin Chen, and we have been heavily working on the vaccine development since the beginning of the pandemic. And also I want to thank Dr. David Ho, who providing a lot of different the viruses for us to test the efficacy against all kinds of variants of concerns. Thank you very much.